Okay. So let's recap what we talked about yesterday. Okay. We need to remember what the standard form for a parabola is. So let's first start off with a parabola that opens vertically. Okay, Kyler, how do we tell in the equation that our parabola opens vertically?
The x is squared.
The x is squared. So we know we're going to have an x minus h, the quantity squared. Okay, is there anything else with the x minus h squared?
No.
No? Layton, what's on the other side of the equal sign then?
4p minus
You agree with Layton? Okay. Michaela, what does the p value tell us? What?
We use like two of them.
Okay. So we use double P to plot a couple points. Good. Maggie, what else do we use P to find? What did you know from yesterday? What do we use P to help us find? Maggie says the focus and directrix. Do you agree? Okay. P is how far away the focus is inside of our parabola. P is how far away our directrix is outside of our parabola. Both of those distances from the vertex. Okay. If our parabola opens horizontally, left or right, Josie, what does that equation look like? Great. Okay. Matt, if we have a parabola that opens horizontally, what tells us that it's going to open left as opposed to right? A positive or negative y, like right here? Okay. Amanda, do you agree with Matt?
No.
Okay, you have a different idea?
Yeah. Like the 4p would be negative.
The 4p would be negative. Okay, Matt, I'm going to come back to you. How do you feel about what Amanda said?
It's better than mine, so I'd go with it.
Okay, so I'm going to get another opinion. Sarah, what do you think? We have two ideas.
I just have no idea, so I just
Don't laugh, because he guessed. Guess is better than nothing.
Yeah.
Okay, so let's see what Sarah thinks. I haven't said if anybody's right or wrong here.
I don't know.
Okay, so let's do this. Sarah, what do the H and the K stand for?
Like for
Okay, so the H and the K, Sarah says, stands for vertex points. Okay, so Matt, I'm going to come back to you. How do you feel about the K being positive instead of negative? If H and K stand for a vertex, how do you feel about your answer?
I would want the H to tell me if it's supposed to open left to right. If the H would be like X value. I don't know.
Okay. How about this? You're saying like if this was positive? Like, is that, I'm just trying to understand what you're saying.
No, yeah.
Okay. So let's talk about this right here. Sarah's told us that the H and K stand for where our vertex are. If that's the case, in this example that I just made up off the top of my head, where's our vertex?
Negative.
Okay, -1, 2. So Matt, because this was positive, we have -1, 2 as our vertex. Okay, which is what you told me, right? Okay. So I'm going to go back to what Amanda said. This negative right here, that is what's going to tell us that it opens left as opposed to right. Okay? So basically, our p-value is what's going to tell us if it opens to the right versus the left. Or when it's vertically, is it going to open up as opposed to down? Okay? So those are the things that we're going to need to keep in mind when we write these equations. Okay, I'm going to give you information about a parabola, and we're going to have to write the equation. Like this. I have a parabola with a vertex at the origin and a focus at 2, 0. So we know the vertex is at the origin and the focus is at 2, 0. Okay. What am I going to tell you to do when you are given this kind of information? Draw a picture. Okay. We have a vertex at 0, 0. So I'm going to label it V so I know which point is which. And 2, 0 is our focus. Cassie, if this is our vertex and this is our focus, which direction does this have to open? It has to open to the right. Okay? And on the last slide, we said that if it opens vertically, excuse me, this is horizontally. If it opens horizontally, then we need which variable to be squared? Y. So we have y minus k squared equals 4p times x minus h, right? Okay. So we know the origin, correct? We know the origin is our vertex. So we can fill that in. Our vertex is at 0, 0, so we can fill that in for h and k. Yeah, I don't know. I got it. Thank you. Okay. Morgan, do we know what our p-value is? What is it? And why is it 2?
Because the focus is 2 from the vertex.
Okay. Our focus is 2 away from the vertex, which means our p-value is 2. So we have y squared equals 4 times 2 times x. Yes.
Do we have a P there?
Well, here, let's do this. Since the focus is 2 away, we know that our p-value is 2.
Oh, okay.
And so y squared equals 8x. I skipped a step I probably shouldn't have. I'm sorry.
Okay, I just want.
Okay. Now Morgan said positive 2. Are we sure that it's not a negative 2 for p? You're saying it is.
No.
Okay, why?
Because it's moving up and to the right. So it's moving up to the right.
Okay, when we open right, p is positive. Excellent. Okay, in this example, we have a vertex at 2, 3, and a focus, so I'm going to label that as a vertex so I know which one is which, and a focus at 2, 1. Eric, what direction is this parabola going to open? It's going to open down. Okay. You don't have to draw it. I'm just going to draw it for effect. It opens down. Which means, first of all, since it opens vertically, we know that the x needs to be squared. Okay, do we know our vertex?
Yeah.
We know our vertex. Be careful, make sure the x coordinate goes with the x and the y coordinate goes with the y. So this needs to be x minus 2 squared and y minus 3. Okay, Michael, do we know what our p-value is?
Yeah.
What is our p-value? -2. Okay. Courtney, do you agree? Why is it negative? Because it's opening down. And why is it 2? Okay, so negative because it's opening down, 2 because the focus is 2 away from the vertex. So we have x minus 2, the quantity squared, equals -8 times y minus 3. If you wrote this as -8 times the quantity y minus 3 equals x minus 2, the quantity squared, that means the same thing. It's not going to matter to me which order you write those in. Okay. Tyler, did you have a question?
No.
Okay. You had a very thoughtful look. Okay. Next example. I want you to do this without me. And see what you come up with. So this time we have a vertex and a directrix. me what you're,
Y plus 1 times square equals,
okay, this is what Sarah has. Comments?
So y plus 1
And can you defend your idea?
because you have to input a number that equals 0. Like, you have to put in
Okay, so you're saying when you plug in this number, you want it to go to 0? So when you plug in 1, 1 minus 1 is 0? Okay. Another way to explain that, that's good. We want it to be y minus k and x minus h. Okay? Okay, so we have y minus 1. Sarah, how do you feel about that? Okay. You got maybe a little excited with the x plus 2. What about the 12? Can someone tell me how she got the 12?
Use 3 because the directrix is 3 spots away from the vertex, so you take that multiplied by 4 equals 1.
Okay, so the vertex is 3 away from the directrix. Good. So our P is 3. Any other comments?
It should be a negative 12 because the parabola opens away from directrix.
It'll be a negative 12 because it opens to the left. Somebody else had their hand up. Is that what you were going to say? Okay. So as I was walking around, I think about half of us had it positive, half of us had it negative. Okay. Remember that the directrix is on the outside of our parabola. If we had this open right, our parabola would run into the directrix. Do we want that? We do not want that. So instead, our parabola has to open left, which is going to make that negative. Okay? Yes.
So does like the h always have to go with the x?
Mm-hmm.
Because I swap those around.
Yes. Okay, that's a very good point too. You don't want to plug them in the order that you see them. The x coordinate always needs to be associated with the x, and the y coordinate always with the y. Okay? Great. Okay. What about if we have a focus at 2, 3, and a directrix at y equals negative 3? So we have a focus and directrix, okay? We need 2 things to write our equation. We kind of need 3. We need to know which equation to use. We need to know the vertex, and we need to know the p-value. Okay? So first of all, what direction is this parabola going to open? Up. Okay? So if it's going to open vertically, we need to use x minus h squared equals 4p times x minus, y minus k. Alright? But we have a problem. We don't have the vertex. How are we going to know what the vertex is? Sean, you have an idea?
Can't we see how much it is, how many places it is from focus from the directrix and divide by 2 to figure out?
Okay, Sean said count from focus to directrix and then divide it by 2. How do you feel about that? Would that make the vertex equidistant from the focus and directrix? I think that would. So let's see, 1, 2, 3, 4, 5, 6. They're 6 spaces away. So where should our vertex be? 2, 0. Okay. So we have x minus 2 squared equals 4p times y minus 0. Okay. So then, Michaela, what would our p-value be? Positive or negative? Positive? Michaela sounds unsure. Can somebody either confirm or deny her idea? She says positive 3. Positive because it opens up. Now she's handing form to her. Sounds super confident because you're right. Okay, it's up, so it has to be positive. Alright. Alright, one more example. This time we don't know anything about a vertex or a focus or a director. We just know 2 coordinates. We know the vertex. Just kidding. I'll back that one up. We know the vertex. Sorry. We know that the vertex is 3, negative 3, and then it passes through 0, 0. We don't know where the focus is, and we don't know where the directrix is, which means we don't know P. Okay. Now, our vertex is 3, negative 3, and we know it passes through 0, 0. I have a problem with this information, though. Okay, what I want you to do is I want to think to yourself which way it opens. And I'm going to count to 3. And after I say 3, I want you to tell me what you think. Everybody all together. Ready? 1, 2, 3. Some people said up, some people said left. Could you draw a parabola that opens up through those 2 points? You could. Could you draw a parabola that opens left through those 2 points? Ah, you could. So there's not enough information. Okay? So I'm going to add that it opens up. Okay? Okay? So we know we're going to have x minus h squared equals 4p times y minus k. Alright? And we know our vertex is at 3, negative 3. So I'm going to write x minus 3, the quantity squared, equals 4p times y plus 3. Now, we don't know anything about a focus or directrix, so we do not know the p-value. How will we find it? Sean, you have an idea.
If you find can you rise up a line, and that's like a line,
Well, we don't know if that's the double p-value or not. It looks like it could be, but we can't count on it. Okay? Since we don't know where the focus is, right? If the focus was right here, you bet that would be great. But we don't know where the focus is, so that's going to be a hard strategy to use. Okay? Other ideas?
plug in a point right here.
Okay, we have a point that satisfies our equation, right? So if we plug it in, it should work, correct? All right, let's try it. We have 0 minus 3 squared equals 4p times 0 plus 3. We plug that in. What do we have over here on the left? 9 equals 12p. So p is 3/4. Okay. Well, then we can come back to this right here. Okay. We know our vertex was 3, negative 3, so we had x minus 3 squared equals 4. Now we know p is 3/4. So our standard form equation is x minus 3 squared equals 3 times y plus 3. Okay. I'm hoping that as we go backwards, it helps you understand the graph that you did last night a little bit more, right? That's what's kind of nice, and this is gonna be our pattern over the next week. When we talk about ellipses, we're gonna talk about how to graph them, and then we'll talk about working backwards. And then we're gonna talk about hyperbolas, how to graph them, and then working backwards. Okay, so this is gonna be our pattern. This is the homework that I'd like you to do tonight. I know it's like, it looks like a lot of problems, but it's really not. I wanted to choose problems that had a little bit of variety as far as vertical and horizontal. Also a variety of types of problems. Okay, so like it looks very random, but it's well thought out, hopefully.